So let's do a couple of examples with these Cartesian plane questions for an acute angle and one for an obtuse angle. So this question says, determine the primary trigonometric ratios of the angle in standard position with the terminal arm passing through the point 5, 2. Round your answer to 4 decimal places. If a question tells you how many decimal places to round it to, make sure you do that for your final answer. Otherwise you'll lose some marks, and we don't want to lose marks. So the first thing we have to do is identify where our terminal arm is, and right now we know that it has to go through the point 5, 2. So find the point 5, 2 and draw it. Second part to this one is making sure that we make our triangle go straight down to the x-axis. So the triangle goes straight down to the x-axis. And the third part is, remember, this terminal arm is always created by going through the origin. So the second part to my triangle here is right there. So this is 5, 2. This is my angle. I'll call it theta. That's the angle I'm working with. My x value along here. X is, oops, sorry. Not x, this one's y. Silly, x, y. Y is 2, and our x value here is 5. So it says determine the primary trig ratios. So all we have to do for this one is, first of all, write down what x is, write down what y is, and now the only other thing we need is r to be able to calculate all of my trig ratios. So r is equal to, remember, it's the hypotenuse. So if we rearranged our Pythagorean theorem, we know that r is the square root of a squared plus b squared. Doesn't matter which one's which. I squared plus 2 squared. So this is square root 25 plus 4 equals the square root 29. I don't know what the square root of 29 is off the top of my head. Square root of 29 is equal to 5.4. Approximately 5.4. Okay. And actually, technically, if we want to be more accurate, since we do have to round our final answer to 4 decimal places, it might make a little bit more sense, if you think about it, if I think about it right now, to keep more decimal places. Just so that our answer is a little more accurate. So now that we know what r is, we can calculate our trig ratios. So sine, cosine, and tangent. Sine, opposite, so katoa. Therefore, sine is equal to, remember, we've got this opposite and hypotenuse, but the other way of writing it now is we know the opposite value is always the y. We know the adjacent is always the x, and we know the hypotenuse is always this r value. So that's our new way of writing it, using the Cartesian plane. So sine is equal to y over r, y is 2, r is 5.3, oops, I forgot to put my angle here, sine of theta equals to 5.3852. To calculate theta, take the inverse sine. Inverse sine of 2 divided by 5.3852 in bracket 21.8013 degrees. This is an angle. Oops, sorry. Okay. So that's sine. Cosine and tangent, exactly the same way. So cosine of the angle is equal to x over r. My x value is 5. R is 5.3852. Rearrange this. Oops, forgot my bracket. 5 divided by 0.3. What do I? What's cosine of 5 divided by 5.3852 equals 21. .8023, and obviously tan for this one is going to be the same. The only thing that's going to be different is the actual ratios. So this one would be 2 divided by 5.852, 0.3714. Cosine ratio for this one, for this angle, would be 5 divided by 5.382 would be 0.9285, rounded to 4 decimal places. And tan would be y over x. Y is 2, x is 5, and that would be equal to, of course, 0.4000. So all of the trig ratios are different, and if you use them to calculate theta, once again we've checked that these are in fact correct because they're the same. So if we have to do the same thing for an obtuse angle, basically the only difference now is that the point is in the second quadrant. It's quadrant 1, this is quadrant 2. So we have the point -3,7 is on the terminal arm of an angle in standard position. So we find our point, -3,7. Use that to draw our triangle. Degrees. Okay. Determine the primary trig ratios to 4 decimal places. So the exact same question. The only difference is this is an obtuse angle. So we're looking at this angle here. Now when we work with this angle, we can still use this triangle. So we use the exact same triangle. This side length is 7. This one is 3. And you can always put the negative there. And once again, we don't know this one. So R is the first thing we need to find. We know x is equal to -3. Y, move that. Y is equal to 7. R is equal to, we don't know. So R equals the square root of 7 squared plus -3 squared. It doesn't really matter if it's negative to find R. In other words, R is always going to be positive because you're always going to square your numbers. So this is equal to the square root of 49 plus 9. And if we punch that in, I think we'll get 7.6158. So let's check out our trig ratios this time. Sine, as we know we can. Sine is opposite over hypotenuse, or in other words, sine is y over r. Y is 7. R is 7.6158. Cos is x over r, -3 divided by 7.6158, and tan is O 7 divided by x, which is -3. So if we calculate these, 7 divided by 7.6158 is 0.9191. negative 3 divided by 7.6158, negative 0.3939, and tan, this one's also negative 2.33, I can't fit, 3, I ran out of room. I try to leave enough room. So the big thing to notice here is that this one's positive because it's sine and it doesn't involve the negative. Cosine and tangent, x is negative, so you end up with negative values. And this is always true, always true for angles that are obtuse. You'll always end up with negative for cosine and tangent.